Okay, everybody, it's time for your next video. This one is all about solving inequalities. So inequalities work a lot like equations, but there's a couple of differences that we will cover here. But other than those, few minor differences, you're really going to solve them just like you solve equations. First and foremost, you need to understand what the symbols are that you're going to see in these inequalities. Instead of an equal sign, you will have one of these four symbols in the equation that you're given. It's still an equation because it doesn't have, well, it's not an equation, it's an inequality, but it's still something that you are solving for. But instead of solving for an exact value, you are solving for a range of values that will make that inequality true. So we need to understand what these symbols mean and what we say when we see them. So I like to think about, I read something from left to right. So whichever end is on the left-hand side, that's what I'm looking at. So this guy, the bigger end is on the left, it's bigger, we say greater than. And when you have the solid line underneath the sign, that means greater than or equal to. Squeeze that in there. So for this inequality, I'm looking for any value that's going to be greater than 6, anything that's going to be bigger than 6. If I see this, I'm looking for any value that's going to be greater than 6, but could also be equal to 6. So 6 and up, basically. So we mean bigger than 6. This one means 6 and up. Okay, 6 or more. Okay, so if this one, the big end is on the left, is greater than, well now the small end is on the left, so that's less than. And same thing with that line underneath, less than or equal to. So I'm looking for any value that is smaller than 2. Or I'm looking for any value that is 2 or smaller. So 2 and down, basically. So smaller than 2 or 2 and down or less. Okay? We've seen these signs before. You guys, come on, elementary school, middle school, you've seen them all over the place. So we're familiar with those. But how do we proceed to deal with these inequalities? Well, one thing that we don't do with equations that we do with inequalities is that we're going to graph them, and we graph them on a number line. Okay? We represent those values on a number line. Because they represent more than one number, we have to shade, and our shading is going to cover all of the potential values that could satisfy the inequality that we're given. Greater than or less than, we have to start on the number line with whatever the number might be. So like if we had one of these, x is greater than 6 or x is less than 2, we would find 6 or 2 on the number line, and we would put an open circle. Okay, that's an open circle. If it was greater than or equal to or less than or equal to, we would use a closed circle on top of that value. Okay, that's a closed circle. Right, so if we're graphing x is greater than 5, then I'm going to start at 0, 1, 2, 3, 4, 5. I would label my number line, give a couple extra. I'm going to find that value, and I'm going to use an open circle because it's greater than with no line underneath. It's an open circle. So I'm telling myself that x could be all of the values bigger than 5, but not including 5. Then we need to shade to represent that, because right now all this number line is telling me that x is 5. Okay, there's just a dot on 5, but I need to shade. When your variable is on the left-hand side of your inequality sign, then you shade in the direction that the arrow is pointing. X is greater than 5, so we shade this way, towards all these positive values that are bigger than the number 5. All right, over here we've got x is less than negative 12. I'm going to call this 0, I'm going to use some liberties here with my numbering. Go by threes. I have an open circle on 12. My arrow is pointing to the left because I'm going smaller than negative 12. So I'm going to shade in the direction that the arrow is pointing. Down that way. Okay? For this one, x is greater than or equal to negative 3, 0, oops, I went the wrong way, 0, negative 1, negative 2, negative 3, negative 4. So because it's greater than or equal to, I'm going to make a closed circle on negative 3. My variable's on the left-hand side of my inequality, so I'm going to shade in the direction that my arrow or my sign is pointing. And x is less than 8. 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Closed circle on 8 because I've got less than or equal to. And I'm going to shade in the direction that my arrow is pointing. I should have some pretty markers to do this with. Sorry about that, guys. Okay, it's really important that you get used to getting the variable on the left-hand side so that you can shade in the direction that the arrow is pointing. When you get into Algebra 2, or even at the end of Algebra 1 when we start talking about systems, and you're going to be, absolute value inequalities, you're going to be shading more than one value on one number line, so you have to make sure that your shading goes in the right direction, because if things overlap, that indicates one thing, and if they don't, that indicates something else. So you've got to make sure you're shading the right way. All right, so that's how we graph things. Let's talk about how we solve the inequalities. All right, crucial rule that you have to remember. When you divide or multiply, when dividing or multiplying by a negative, so we're talking about like a two-step equation scenario here, or even a one-step where it's just like this one, where it's just multiplying. If you are doing any dividing or multiplying by a negative number, you must flip the sign. You change the direction of the sign. You change the way it's pointing. Okay, and then you graph your answer on the number line. All right, so we'll get to an example where we have to do that. But first, let's start with this one. X minus 3 is less than 5. So just like a regular old one-step equation, we'll add 3 to both sides to cancel this out and get the x by itself. And now we have x is less than 8. So we'd go 0, 2, 4, 6, 8. 8, this would be 0. Open circle, shade in the direction that the arrow is pointing. A little squiggle. Okay. 6 is less than or equal to negative 3/5 W. Okay, this is a doozy. We are going to have to divide by a negative fraction. Woof. So I don't divide by a fraction. I don't divide a fraction by a fraction, I should say. Instead, I change it into a multiplication problem. And in order to change it into a multiplication problem, I have to flip the fraction before I do the multiplying. So I will have 6 less than or equal to negative 3/5 W times negative 5/3. So that will wind up canceling. This will become 15 over 15 W, right, because negative 3 times negative 5 is positive 15 over 5 times 3 is 15. The W is still there. This just becomes a 1, so it cancels, which means I have to multiply 6 also by negative 5/3. So now I have technically divided by a negative, but my action is multiplying. So I'm going to flip this sign. I've got my W left over here. 6 times negative 3/5 is negative 30 over 3, which means negative 10 is greater than or equal to W. Now wait a second. My W is on the right, and I want to make sure that my W is on the left so that I can shade without getting confused. So really, I'm going to do what I like to call the pancake. I want you to visualize sticking a spatula underneath this expression, picking it up, and flipping it over. So you get W is less than or equal to -10. Nothing changes about the value. We're just getting this on the left-hand side. But we can't just flip-flop them and keep the sign the same way. So we're flipping it up like a pancake, turning it over, the exact same thing, just reversed. So now we have W is less than or equal to -10. So I'm going to say these go by 5. Less than or equal to gives me a closed circle. And I'm going to go down that way. Okay, so we had to change the sign there because we were dividing by a negative, technically. Dividing a negative fraction by a negative fraction, in which we changed to a multiplication problem by flipping it over. A lot of flipping going on there. Flipped here, flipped the sign, flipped the flapjack. We're just flipping all over the place. Okay, let's try number 3. -15c minus 28 is greater than 152. All right, so I want to isolate my variable just like in an equation. So the first thing I'm going to do, this is a 2-step, is add 28 to both sides. Now it cancels here. And I have -15c is greater than 180. Now I need to divide to unstick the -15 from the c. So I'm going to divide by -15 and divide by -15. That gives me c. My sign flips. 180 divided by -15 is -12. So c is less than 112. Let's see, 0, -4, -8, -12. Got an open circle on -12, and I'm shading the direction that the arrow is pointing. These have all been less than so far. It might stay that way. Okay. Let's do another one. 4x minus x plus 8 is less than or equal to 35. So 4x minus x gives me 3x. I'm going to combine those like terms. 3x plus 8 is less than or equal to 35. I've got my 2-step now. Get rid of the 8. Cancels out. And I've got 3x is less than or equal to 27. Divided by 3. Divided by 3. And x is less than or equal to 9. So I'm going to start down here at 0, 5, 6, 7, 8, 9. Here's 9. And I'm going to make a closed circle because we've got the line underneath the sign. And I'm going to shade in the direction that the arrow is pointing. My shading is getting worse as we go. Yikes. All right, we've got 2 more. 2 more. Are we ready? All right, 7x plus 6 is greater than or equal to 7 times x minus 4. So we have to get rid of those parentheses by distributing. 7x minus 7 times 4 is 28. Oh, what do we have here? I want to move the variables because this is variables on both sides now. Positive 7x, I'm going to subtract and subtract. Well, now I've canceled out my variables on both sides. And just like an equation, this statement can't be true because 6, while it is greater than -28, it is not also equal to -28. No solution. Skip the step of graphing. Isn't that great? Okay, let's do this last one. We're going to distribute the 2 to get 6m minus 10 is greater than 12m. Is this a plus 6 or a divided by 6? We're going to go with plus 6. All right. So now I want to get my variables on the same side. I'm going to subtract 12m and subtract 12m. 6 plus -12 So I'm combining these things. It's going to give me negative 6m minus 10 is greater than 6. So I'll add 10 and I'll add 10. And now I have negative 6m is greater than 16. Oh, I smell a fraction coming up. All right, we divide by negative 6 and divide by negative 6. And that means, I'm going to carry this up here, m, the sign flips, less than, let's see, 16 divided by 6, well, negative 6. We can't do that, but we can reduce. I can put 2 into each of those. 16 divided by 2 is 8, and 6 divided by 2 is 3. So m is less than negative 8/3. I'm going to turn this into a mixed fraction so we know where to put it on the number line. 3 goes into 8 2 times, and there's 2 left over. So we have m is less than negative 2 2/3. We're going to do 0, 1, 2, 3. We'll find negative 2 and about 2/3. It's an open circle, and our shading goes to the left. So really, if you guys know how to solve these equations, these multi-step equations, and especially the two-step equations, this should not be a problem for you. You have to remember that critical rule of switching the sign, flipping the sign, the direction of the inequality sign. When you are dividing by a negative during the process of solving, you must change the direction of the inequality sign. Other than that, just remember to put it on the number line and you'll be golden. Write down any questions that you have. We'll practice this in class tomorrow before we get into literal equations. And I will see you then. Great job, guys.